Hello, here's the week 7 lecture of our smart things security. Okay, will be cover was the cloud security. So we will go through like maybe some idea of what is the cloud and then the related security. Okay, how can we manage and secure the IoT data in the cloud? So here will be the key or like one of our core in our structure, because start from our website, the edge components, and then sending the data to our server, and then those server maybe one will be the cloud server, and then we also like store the data. Okay, so for the cloud, we know we try to provide the scalability, including the data storage, also the processing power, because after we receive the data. Okay, so how can we like process or go through certain calculation, okay, process, okay. And also it can provide, maybe we have a platform and then it helps us to like remote access for the IoT applicants, okay, applications. So all these like they are all possible, okay. And the IoT devices, like typically they cannot store or like process all their data locally. Here's the issue, because maybe we use a Raspberry Pi to simulate, okay, what we're doing, but maybe sometimes we are not using those like really powerful devices. So they're only sending the data to the cloud for analysis or storage, okay. And then the benefits why we are using the cloud for IoT, because we can easily centralize all those data, and then we can do analytics, okay. And then also we can have a real-time monitoring the data like for control devices like from anywhere. So you can use the app through the platform to remote access or control, okay. And the scalability. So if we have more devices like connected and rapidly going up, then we can easily to scale up. Okay, so here's the idea. Here will be the recap. Like maybe we repeat so many times about the types of the IoT data. We're going to store like maybe some sensor data, all those like temperature, motion, humidity, GPS, all these. Okay, and the metadata. Okay, so all those are metadata, including the information of the devices. Okay, maybe the timestamps or data. So we always, especially for our smart things like IoT devices, all the data always come with the timestamp, because it's important, like for analytics to also maybe some usage patterns that are important, okay. And also we can have some like commands or like configuration of data. So we can send it from the cloud to control the IoT devices. So that's one of the idea. Now we can do like sending or like so sending those like commands, they can like operate. Okay. So just imagine like, okay, if you want to like your recipe we put from the cloud, then how can we do that? So there's a question, of course, in the lab, then I would like to try. And for the data flow, okay, so we know from the IoT, so of course we from the edge device, okay, and then go through the gateway and then go to the cloud. Okay, physically, okay, the architecture will be like this. So this is like followed by the data processing and then the storage and visualization outing to the user, and then that's what we're doing in the cloud. And then we also have the cloud-based analytics. So those process the large volumes of data generated by the IoT devices, and they can provide some like actionable insight. So this like we're going to do. Then why the cloud security is crucial? Mainly is like the CIA. So in cybersecurity, we learn the CIA. So we try to ensure the sensitive IoT data. So this data not exposed to unauthorized parties. For I will be the integrity. So we try to ensure the IoT data remains accurate and also unaltered during the storage process and transfer. Okay, and availability. So we try to make sure the surface remain accessible and operational even under heavy load or during attack. Okay. Yeah, and for confidentiality, of course, like how can we like work on the IAM those like file access, okay, integrity, okay, how can we make sure we make accurate, okay, consistent availability, then how can we let the service always like make it alive online, okay. And possible data protection, how can we do that? Always like come with the encryption, okay. We call it at rest or in transit. Okay, at rest that means we store it like in the car, okay. And then in transit that means the transmission. So like we did cover like somehow like in transition, then we try to use the TLS, SSL, okay. At rest, okay, we also have some encryption and also the protocol we try to use right here. So to secure the communication. And one part we did talk about is authentication and authorization. So we try to ensure the IoT device provide the identity to access authorization. That means that what the actions that authentication they can perform. Okay, so the example we say if there's a thermometers, then it only can read the temperature related information, but not others. Okay. And also then the data availability, then how can we handle with the DDoS, the distributed denial of service? So we can protecting the cloud platform from the DDoS attack. So make it unavailable, and also the fault tolerance. How can we ensure the cloud infrastructure can recover from failure? Because in our cybersecurity, we have a topic like talk about risk and management, and then one part of it is about like backup and recovery. Okay, so because like we will calculate about the cost, right? So if most time, how can we so part of it is how can we recover from the failures and ensure the continuity of the service? Okay, to make sure it's always available. And next will be the device identity management, as well as not only the access, but also the device authentication. So the some techniques like the X509, so certificate, and then or we can use some like secure key, okay, to authenticate the IoT devices. And also we maybe assign a unique device ID. So we will see some of performance. We will try to do adaptation. So they we can make like uniquely identifiable. Okay, monitor securely. So once we have one new IoT device, okay, try to add to the platform count. Then how can we assign a unique ID? Okay, or like bind with the them address. Maybe it's possible. Then we can do it in this way. And here would be the model we are using for our cloud computing. So mainly would be three. Actually, there's one more for the next. Okay, mainly would be we could ISAC and then PAX or attacks. So the infrastructure as a service. So it will provide the virtualized computing resource over the internet. So maybe there's some like the virtual machine, provide some storage, give you like certain bandwidth like the network. And then for the passive, so will be called the platform as a service. Okay. So what's a platform? So will be allows a customer to develop, run, and manage some application. So they don't have to like deal with the underlying infrastructure. So you see from the models like for the ISAs, so would be like infrastructure based. So you need to like work on it. Okay, start from the VM, then we need to build on as an infrastructure. And then we call the software as a service. So we call that, and it could be try to deliver server software application over the internet. So it's more like running on the cloud-based analytics platform IoT application. So we're just using the application, or sometimes we call it subscription. Okay, subscribe and that's it. So we only use their software. And for platform, so create the platform. We have so many. And why these like different type of models like affect like is method for the IoT or like the smart things? Because we need to think about each model. They maybe have like different trade-off. So in terms of like scalability, control, and flexibility for the IDE solution. So we need to choose like, okay, for the project, so which model will be better fits to your, okay. And so for details, so for the infrastructure as a service, so in IoT, so it can allow the organization to rent computing resources, such as like the server, storage, and network infrastructure. The one maybe you use called EC2, so it will be under this model. Okay, so after you choose, you can like build your own instance or the nodes, and then you can choose different processing power, bandwidth, like as what you need. So you can pay for it. Okay. And how it this like fits with the IoT? So it can help to scale up easy. Like maybe we can store some massive amount of IoT data, including if you have some like video. So if for camera, okay, or like you have camera need to record certain data, sensor data, and then for the compute power, so it maybe needs a high performance server to process really large amount, okay, for of real time data or do the analyze, then it can be a good model we can use. And what kind of security consideration for this kind of model? Then we need, okay, for the virtual network isolation, so make sure the IoT traffic, they're isolated from other network traffic. So maybe we can use called the virtual private count, and also the IAM, the identity access management. So how we can control the access of resources, like who can access it to the folder, directory, files, okay, data, and then also the encryption. So we call it at rest, right? So how can we encrypt the stored data on the cloud server? And then also in transit, how can we encrypt the communication with the IoT devices, just like this. So we will using those today. Then we will for the next model will be platform as a service, right? Then so as what we say is platform for us to develop and running and managing application. So one might be for nowadays is pretty common. So you know AWS, Google, IBM. So they have giving the platform for you to build an IoT. Okay. And for this one, you just need to manage the like they already create the environment, so you don't have to really care about the infrastructure. So for your developer, you just need to build your own application. Okay, so maybe there are some tools that you can just like collab, process, store, analyze some data for the devices. So you don't have to worry about like the hardware. The hardware will be like maybe the CPU, RAM, storage, okay, or the network bandwidth, okay. So what's the benefit transfer in, transfer out? So you don't have to care about all this. And only one thing is the API. Okay, so how can we secure the API? So because the API will be the communication part. So you see for infrastructure actually we cover a showing part, and then but we don't have to care about the infrastructure. Then for the communication, then how can we make sure the API like secure it? So try to prevent some unauthorized access. So you see that we keep on like repeating talking about like authentication, authorization like this. And they need to secure the authenticate before they connect to the platform. And also we can use the called the role-based access control. So we can restrict certain access to the platform. So based on their role and responsibility. Okay. So here's one of the options. And then another one called the surface as the software as a service. Okay, so we say we just like running the software on the internet. So what we need to do is just like install it and then maintain the software locally. So even for the Google, Azure, or AWS, they also give you certain management. Okay, and for this, maybe if you want to like provide some IoT specific service, like maybe device management, data analytics, or some visualization tool, then you can use it. Okay, so you can visualize those real-time data through all this surface software. And for this part, then you need to care because you're not you don't need to take care of the infrastructure. You don't have to manage the platform. So mainly first part will be your account security. So how can you ensure your account being protected with the strong authentication mechanism like to FA? Okay, and also the data privacy. So how can like ensure the personal or sensitive data collected by the outage user that protect from unauthorized access. Also the convenience. So how can we make sure the SaaS platform so stable from regulation? Okay, all this like we talk about regulation, all this. And when we decide, so here would be the comparison so of the all these like if we say which one would be better. If we think about scalability, always like the ICE. Okay, so we offer maximum flexibility, and tax will be depends on your use, and then for tax just a simple. Okay, there are limited customization, and you need to think like when you compare flexibility and then like versus with the convenience. Okay, when you have a full control of the environment, but for such easy to implement. So with the least control. So you think like if your it's a big project required to have fully control, then you need to think about like working from the infrastructure. Okay, maybe sometimes they're not fit to your project. Okay, also called the cost efficiency, the next one. For the infrastructure will be cheaper, but require more like management. Okay, and then if you like use the software, would be most expensive but easy to use. So this is not a definite answer, but we do have some like use case. Maybe if you have some IoT application need to some customized infrastructure, like for a really complex device network, then you maybe choose the infrastructure one. And if you just need to do some like real-time analytics, okay, really quick development, okay, with some built-in service, you can choose a platform. Then it's good enough. But for business, you just need to like use some like ready-made solution. Okay, maybe some smart home monitoring, just like add the device and plug in sending data. Then you can choose the software-based model. So it's all good. And there are some risk of the cloud IoT platforms, so including like the data breaches, so will be unauthorized access to the sensitive data stored in the cloud, and the insecure devices, as well as we have weak security, always come with the default password, patch the firmware, so always like easily they compromise, and then insecure API during the communication. So there's some unauthorized access or the man in the middle attack. So it will make some malicious interaction with the IoT devices. And most always that happen would be the misconfiguration. So the car platform have some really complex configuration, and then sometimes you have to turn it on or turn it off like this. So maybe when you misconfigure some like surface, okay, let's say the public storage buckets overlay, it permit safe like IAM policies, so it can lead to the data leaks or unauthorized access like this. So we need to be careful. And then let's say for the AWS IoT, okay, like this one. So there are some we can look at like popular example. So devices can be like compromised. So if they maybe have a proper authentication or encryption, so they're not configured. Okay, so that's why maybe some mitigation. So we can use the called the IoT devices defender for the anomaly like detection, or we can use the 509 certificate for the devices authentication, and then we can implement some strong access control. That's like we can do. If we mentioned the Google Cloud IoT, so one thing is about the data in transit, right? So it can be like intercept. So if there's no proper encrypted, and then device identification. So maybe kind of weak. So possible we can choose like Google Cloud IoT Core with some like good authentication method. Okay, so as well as the OAuth or the JWT tokens to enable end-to-end encryption. You see, we mentioned that all these are actually in our some popular cloud IoT platform. We are using all this method. Okay, so you see, and We have some. So let's say for some like healthcare IoT provider, if they suffer from the data breach, and then because the sensitive health data when not anchored in transit, then they may be like exposing the patient's data to unauthorized user or some like smart home companies. So they also some people due to some default credentials on the devices. So the hacker can control the user's smart home system. So all these is possible once mm, the cloud platform they're not like very secure. And for the mitigating the security risk, we also have some different type of encryption. Probably do using TLS SSL to secure the data in transit. Okay. Also, we can use the AES-256 to encrypt the data at rest. Okay. So right here, usually maybe the method is pretty similar, but how can we implement? That's like what we're going to do. Okay. And then for the authentication, so we can make sure that as well we repeat it, you can use the 509 certificate for the device authentication, or the use the old auth 2.0, like when 2.0 or GLT for the user authentication. So like this. And the next part, and access control. So we always implement the role-based access control or the least privilege principle to restrict the user and the device access only to their like necessary resources. We can do it this way. And more like we can do the device identity management. So we can some secure device onboarding or life cycle management practice like this. Or also we can add some like device key management, and always perform regular key rotation, so it can like secure the device. Okay, that's security. And sometimes we can do like in the network security, so we can separate network or using called a virtual private cloud VPC. And also, if you know the terms, like also we can apply the firewalls, VPN. So it's also possible. It can help us to secure the communication, all this, and always like to practice continuous monitoring. So maybe we need to have some monitoring tool to track the device activity. So no one like maybe logging all these like activities, and then with the cloud interaction. And then we can use some detection to detect if there's some unusual behavior, okay, or like certain action. And for the service provider, we say that different type of providers, so maybe right now they have some features like updating. So that's what we say for the AWS, they have one called IoT Device Defender, so they will provide some continuous monitoring or anomaly detection. We can IT core we're using that device authentication, secure device communication, and API security. Okay, and I am using for Google Cloud IoT security. So it's cloud identity and access management. So they have control all the resources and then the IoT core. And also they can secure the device authentication, encryption, access control. So you see, different platform, they have like all this strategy, the way for secure feature, pretty similar. And that's what I'm doing. And also they will follow certain standard as well as a GDPR. Okay, so it will be the data privacy, like for the EU or related to the IoT will be HIPAA. So we like ensure security. Okay, for the healthcare related, or some cybersecurity improvement act, or the ISO IEC 2701. So will be a firmware secure information access. All these like try to like follow. And actually, there's one more to use the AWS IoT core for the lab, but really some of this that we have to pay for. So I just as usual, I skip the lecture lab, and this part so I prepare another ones that we build our own. So if you're interested, you can check on this lab and some steps. So you see mainly like register your IoT device and get the SDK. and then get the tool for communication. Okay, so how can we get the generate the X509 certificate and then set the policy? And you'll see one of the new assignments. So remember, you need to take a screenshot, like all the steps. So like to show me how if you are able to like install all these. Okay, so let you to experience how can we set up, and then also we have the TLS, like using the OpenSS to generate your certificate. All this actually you will see pretty similar, but as a basic, like if we have our own count and then set up the communication, then I think it would be better for practice. And that's it for this it is our lecture. So hopefully here we go through what's the important of the securing the IoT data in the cloud, and then including what those like based on different model. Okay, so maybe we need to choose like which one is better for our IoT project. Okay, and that's it. Next week will be our before the spring break, so will be the last week before assignment. So I will go through actually it will be like how showing how can we integrate like from Raspberry Pi sending to our API server, and then save the data to the database, and how can we retrieve the data as a complete connection. And for after I will post the new assignment soon, so you can spend your time on your spring break and prepare. So it will be kind of a revision for your previous lab. So it will be a short quiz. Okay, kind of like you can create a midterm or a short quiz. So it's not that complicated. We cover until our week 8 lecture. Okay, so you have a week to complete it. So actually you can prepare in spring break, and then because you will be taking, just like let you know earlier, I will make the notice. So after the spring break, and then the next coming week will be no lecture, but you can prepare for taking the midterm like this. Okay, and that's it. Thank you.